Greetings and welcome to your geometry recording. We are in week 5. We're also in the week of February 6th. So at this time, please make sure you've got your math notebook out. Remember, I do want you to take notes to turn in at the end of the week as you watch this recording. So if you don't have your math notebook out now, go ahead and click pause and grab that. And as always, I'm going to start with a warm-up question that I do want you to try in your math notebook. And this will help you as you review Unit 5 and get ready to take the Unit 5 test, which is coming up. We're taking it this week, actually. So great way to see if you're ready to take the Unit 5 test. So the Unit 5 review question, the warm-up, is that I want you to tell me if the measures 7, 15, and 20 can be the sides of a triangle. So can these sides make up a triangle? And if so, take it a step further and classify the triangle as acute, right, or obtuse. So go ahead and try this in your math notebook. And when you're ready to check your work with mine, go ahead and click pause or play. All right, so we are going to use the triangle inequality theorem to first determine if these side legs can in fact form a triangle. So what we are going to do is we're going to add two of the sides together. And remember, the triangle inequality theorem says that when you add any two sides, the sum needs to be greater than the third side. So we're going to do this for all sides and make sure the sum of the two sides are greater than that remaining side. So we're going to add them all together and see if we can in fact even form a triangle. So we'll say this is side A, this is side B, and this is side C, just to make sure we add all the sides together and check all the side combinations. So 7 plus 15, what do we get when we add 7 plus 15? And is it greater than 20, that sum? So 7 plus 15 is 22, and 22 is in fact greater than 20. So this is a good thing. So let's keep going. B plus C, so if we add side B plus side C, that sum should be greater than that third side. And looking at that right away, I know it is, right? We know if we add these two together, both of those are greater than 7, those numbers. So the sum would have to be as well. And then we're going to add 7 plus 20, and that sum, is it greater than 15? It is in fact, right? Because, wait, 27 is greater than 15. So we know that, yes, the sides do form a triangle. And now, what kind of triangle? Is it acute, obtuse, or right? So now we're going to use the Pythagorean inequality theorem to see what kind of triangle it is. And the the Pythagorean inequality says that if we add a squared plus b squared, and then look at how it is in terms of c squared, whether it's greater than or less than, and we'll figure that out, or equal to, whether we have a right triangle, an acute, or obtuse. So this is what we're going to do to figure out what type of triangle we can create. So I'm going to change colors now so that we can see this work. So remember, the A and B terms are always the smaller legs, and the C term is always the longest leg, or the hypotenuse. So this is already in order for us. So I'm going to come up here now. So we're going to have 7 squared plus 15 squared. I'm going to put in a circle here to let me know I need to put in an inequality based on what we get. So 7 squared is 49. 15 squared, 15 times 15, we know is 225, and then 20 squared is 400. Let's add 49 plus 225, and I get 274, which is actually less than 400. So what we're getting here is less than. The sign that we're going to be using is that when we add a squared plus b squared, it's less than c squared. And because it's less than, that means it's an obtuse triangle. It's an obtuse triangle. So if we have a squared plus b squared is less than c squared, that's obtuse. If you get a squared plus b squared is greater than c squared, then you have an acute triangle. And if it's equal, we know that it is a right triangle. All right, so some good review there. You'll see problems like that on the Unit 5 test. So what are we doing this week? We're going to take the Unit 5 test. Then we're going to take the Unit 6 pretest. You guys will get a good view of what you'll be learning about in Unit 6 with the pretest. Remember, it's just a pretest. You'll earn full credit for completing it no matter how you do. It's just for you to see what you're going to be learning and what you do and don't know, and then you're going to do all the learning as we go through Unit 6, so it's okay if you don't know stuff. And then we're going to start on Unit 6 with Unit 6 Session 1, and Unit 6 is all about probability. All about probability. So we're going to start Unit 6 with learning about theoretical and experimental probability. Oops. So let's take a look at that. So what does probability mean? So probability tells us the likelihood of something to happen. And the most general thing that we can look at is just the overall probability of an event. And in Unit 6, you're going to start seeing some fancy notation, such as this, P, and then I've got parentheses and A. And what that means is probability of event A occurring. So instead of writing out probability of an event, we can have a shortcut and just do capital P and then in parentheses what we're trying to find the probability of. So in a nutshell, probability is just taking the number of ways that a certain event can occur that we're trying to find the probability of. In this case, if we're trying to find the probability of event A, we're going to put on their numerator the number of ways that event A can occur. And then on the denominator, we're going to have it over the total number of possible outcomes. So let's look at a pretty easy example. So I've got a picture of some cute puppy dogs down here, and I want you to tell me what are the chances of, if you were to reach your hand in without looking, that you would pet a, yellow lab, picking a yellow lab. So the fancy way we could say is P, and then do yellow lab in parentheses. And that means we're trying to find the probability of picking a yellow lab. So how many possible ways can we choose a yellow lab? Well, there's 1, 2, 3, 4. So we got 4 chances of choosing a yellow lab. And then how many puppies are there in total? 1, 2, 3, 4, 5. So out of a total of 5 dogs. So your chances of choosing a yellow lab would be 4 out of 5. So one way we can write probabilities is a fraction. We can also write it as a decimal. So 4 divided by 5 is 0.8. And we can also write it as a percentage. So 3 different ways that you can express your probabilities: fraction, decimal, or percentage. And usually I will let you know what I'm looking for in the problems. All right, so theoretical or experimental? So theoretical means what is expected to happen. So what is expected to happen is what experimental means. What is expected to happen? So like, for example, if you toss a coin, you have a 50-50 chance of choosing heads or tails. That's an example of a theoretical. It's what is expected to happen. Where experimental is when you actually carry out you carry out trials. So you're doing it a number of times. the best way to think of experimental is what actually happens through trials. So if you were to toss a coin, throw your coin up and note each time if it landed on heads or tails, and that is where you would then take your probability from, is keeping track of the number of heads and tails and basing your probability on that experimental data. So let's look at some examples here and decide whether each situation, we've got 3 different situations, if it's an example of theoretical probability or experimental. So if I were to just say, if we toss up a fair coin, what is the probability tails will show up? What do we think? Is that theoretical or experimental? It didn't say anything about actually doing that or tossing it. It just said, what do we expect to show up? So that is going to be based on theoretical data. So what is expected to happen? So that would be theoretical probability. So now let's look at the second one. A bag contains 20 marbles. 15 of them are red, 5 of them are blue in color. Find the probability of picking a red marble. So again, we would base this probability on what we expect to happen. So this would be theoretical. And what would be that probability of picking a red marble? So 15 of them are red, so we have 15 different reds to choose from out of a total of 20. So that would be 15 out of 20. Or we could reduce that to what? Divide out of 5, 3, divided by 5, divided by 5, 3/4. The last one, you are using a simulation tool. So you're actually trying out different trials here to find the probability of rolling a 3 on a dice. You roll the dice 50 times to collect your data, and then your probability is going to be based on your data. So this one is actually going to be experimental, right? Because we're basing our probability on our collected data. We've actually done the experiment. We've experimented. So that's experimental, based on what actually happens through trials or simulations. All right, moving on. All right, so let's do some more calculations. Let's practice finding some probability, experimental and theoretical. So experimental based on trials, and theoretical what is expected to happen. So we've got an aquarium. And our aquarium is stocked with 4 different types of fish. So in the aquarium, we've got 25 neon tetras, and we're going to abbreviate that with N. We've got 18 swordtails, that's a type of fish, we'll abbreviate that with S. 12 platies, abbreviate that with P, and 3 catfish, abbreviate that with C. So you guys are on a field trip at the aquarium, and you're recording the number of fish observed in the aquarium. So during a 15-minute time period, the class observed, so what you wrote down was that you saw 18 neon tetra, 12 swordtails, 9 platies, and 2 catfish. So let's look over here on the left, and let's start with determining the experimental probability of observing a neon tetra. So we want to find the probability of observing a neon tetra. So I'm going to use our fancy notation, capital P to represent probability, and then N, remember, represented our neon tetras up there. So because we want to find the experimental, which data are we going to use? Will we use the stuff up here that tells us the total number of each type of fish? Or will we use the data down here that you gathered when you were observing the number of fish and counting them in the aquarium? So we're going to use this data here, what we've observed and written down as our data. So how many neon tetra did we see? 18. And how many total fish did we observe? Well, we've got to add up 18 plus 10 plus 9 plus 2. So 18 plus 2 is 20, plus 19, 39 is a total. And that's going to go in my denominator. So if I want, I could stop right there. If I wanted it as a fraction, my probability, or I could write it as a decimal and a percentage. So as a decimal, it will be 0.46, and as a percentage, that's 46%. I rounded to 2 decimal places, by the way. All right, so that's our experimental probability. But what about our theoretical? So theoretical is going to be based on the total numbers that are in the aquarium and what is expected to happen if we were to try and find the probability of observing a neon tetra. So let's do that. I'm going to change font colors here. So we want to find the theoretical now. So how many neon tetras are there total? 25 to choose from. And the total number of fish is what? 25 plus 18 plus 12 plus 3. So add all those together, and what do we get? Total of 58 fish. So again, we can leave it as a fraction, or we can write that as a decimal, or we can write that as a percentage. Okay, so that is a great example of the difference. When you're finding experimental probability, you're going to use data to find the experimental data, or probability, where theoretical is based on what's expected to happen. Moving on. And that's all. So let me put up your key phrase assignment. So a student is keeping track of throwing a coin up in the air and tallying how many times it landed on heads and how many times it landed on tails. So your first step is to find the probability using in number 1, and then is this an example of experimental or theoretical probability? So answer both those questions. Remember, you do need to submit your notes from the recording, so make sure you took good notes. And then remember, you do have the Unit 5 test this week, so make sure you're studying for that. A great way to study is to redo low-scoring assignments. So let me know if you need any help this week. Otherwise, have a great rest of your week. Up